In this lesson, we're going to learn about rational expressions. Rational numbers are numbers that can be written as a fraction p over r if r is not equal to 0. Examples: 5/7 or 12/5 or 3/27. Those are rational numbers. Rational expressions are expressions written as p of x over r of x, where r of x does not equal 0. Examples of rational expressions include things like this: x plus 8 over x squared minus 64, 7 over x plus 7, x squared minus 4x plus 4 over x squared plus 3x minus 10. These are all examples of rational expressions. So we can reduce rational expressions just like we did with numbers, just with regular fractions. So to reduce a fraction such as 24 over 28, remember we must factor the numerator and denominator so as to find the largest common factor, and we'll divide it into both. So here's my example. 24 I can rewrite as 4 times 6. 28 I can rewrite as 4 times 7. And since 4 over 4 is equal to 1, I can cross those out, and I can reduce this to 6/7. With rational expressions, we must do the same thing. So let's take the example of x plus 8 over x squared minus 64. In the above case, the numerator is considered prime, like 2 or 3, because there's no more factoring that can be done. X plus 8, that's it. But the denominator is a difference of squares, so we can factor that into the following. We can change the bottom into x plus 8 times x minus 8. Now, we can cross out the x plus 8 over the x plus 8. Again, that equals to 1. So we are left with a 1 in the numerator over x minus 8 in the denominator. Now we're going to do a couple of samples of reducing rational expressions. Let's begin with the problem on the left. So I'm going to start by taking a look at the top, and I see that 5y squared minus 5 has the first thing I should always look for, which is a greatest common factor. So I'm going to go ahead and factor that as 5 times y squared minus 1. And on the bottom, I notice that 3 is a greatest common factor. So I'm going to go ahead and take 3 times y minus 3. Or excuse me, y minus 1. Let's go ahead and erase that real quick. All right, there we go. Now I do notice that on the top, y squared minus 1 can continue to be reduced or factored because that is a difference of squares. So let's bring down what I have so far, the 5. Now I'm going to factor the y squared minus 1. Well, being difference of squares, I know that I'm going to take the square root of y and the square root of 1, put them in the beginning and the end of the parenthesis. One parenthesis must be a positive and one must be a negative. So addition and subtraction. Now the numerator is completely factored. Now I'm going to check the denominator. Well, there isn't anything else I can do with that, so we'll just write down our 3 times y minus 1. Now again, I'm looking for terms that I can reduce by themselves to equal the one whole number. So I can see here that y minus 1 over y minus 1 is equal to 1. Now remember, I can't just take a single y or a single number out of a parenthesis. We have to treat that parenthesis as a single number. So for example, y minus 1 could be the equivalent of 10. But I can't just take, say, 7 out of 10 to reduce with a 7 on the bottom if it's just an addition problem. It only works with factors. And that's what I have here, factors being multiplied together. Once I've crossed out everything I can reduce, I look to see what's left. So in my case, in my numerator, I have 5 times y plus 1, and the denominator just has 3. Now, depending on what you are working on, you may need to multiply that back out, or you may be able to leave it in this format, depending on the problem or what your teacher is asking for. If we were to multiply through, it would simply look 5y plus 5 over 3. Now let's look at the second example on the right. This one looks a little more complicated, but not really. It just has more terms on the top and more terms on the bottom than we had before. So let's begin again with our process of looking for the greatest common factor first. So I can see that there is an r that is common with all three terms, and there is a 2 that is common in all three terms. So I'm going to factor out a 2r, and that will leave me with r squared for the first term minus 7r for the second term plus 10 for the third term. Now I'm going to be able to refactor that top. Let's go ahead and factor the bottom. R squared plus 2r minus 8. So two numbers who multiply to be 8, whose difference is 2. So we're going to have here r plus 4 and r minus 2. Again, I can check that by multiplying out my binomials. I will see that positive 4r and negative 2r is a positive 2r. So knowing at the top, I still have some factoring to do with r squared minus 7r plus 10. So we're going to take r, put that in the front, two numbers who multiply to be 10, who add to be negative 7. Well, that's going to be minus 5 and minus 2. Now the numerator is completely factored. And now I'm going to look for anything that I can reduce top and bottom. So in this case, I see an r minus 2 on the top and bottom. That equals to the whole number 1. And I'm left with 2r times r minus 5 over r plus 4. And if we need to multiply it out, 2r squared minus 10r over r plus 4. Here's a problem that I'd like you to try. See if you can reduce it. Pause the video, try it out for yourself, and when you're finished, unpause the video and check your work against mine. All right, let's begin by factoring the numerator. R squared plus 9r plus 20. So we're going to factor that into our two binomials. Two numbers who add to be 20, or excuse me, multiply to be 20, but add to be 9. So we're going to go with r plus 4, r plus 5, and r squared plus 8r plus 16. That's a perfect square trinomial. So r 16 is 4 times 4, and they should all be positive. Now I can see that I have one pair of expressions, r plus 4 can be divided by itself to get us the whole number 1. And so all we're left with is r plus 5 over r plus 4. Congratulations.